Hello, good day viewers. Still on quadratic inequalities. Today we have this rational function x² minus x minus 6 divided by x² plus 4x minus 5. The whole of this greater or equal to 0. And we are looking for those real values of x that can satisfy this inequality. So if you are new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload a new content. And don't forget to share to your learning colleagues. Alright, let's get started. Before we continue, I would like to factorize both the numerator and the denominator. To the top, we're going to think of two numbers that we can multiply to get -6. But the moment we add the two numbers together, we shall obtain the coefficient of x, which is -1. And the numbers are -3 and +2. So we have x minus 3 multiplied by x plus 2. This is our numerator because -3 times +2 is -6, and this plus this will give us -1. Divide by, we do the same thing here. We think of two numbers that can be multiplied together to get -5, but the moment you add the two numbers together, you're going to get +4. And the numbers are -1 and +5. -1, +5. The whole of this remain greater or equal to 0. Remember, I told you the bottom cannot be equal to 0. And what are those values of x that can make the bottom to be 0? They are +1, -5. So let me bring them here. X cannot be equal to 1, and x cannot be equal to -5. Talking about domain. So let's continue. So if the whole of the left hand side is greater or equal to 0, it implies that this is what? Positive. And on what condition will this be positive? It is either if the top and the bottom are all positive, or the top and the bottom are all negative. Because, for example, remember, 5 divided by 2 is positive. Likewise, -5 divided by -2 is still positive because the negatives will cancel. So we are going to assume that this is positive, likewise this is positive. So we have first condition. Then this is negative, this is negative. So let me start with the first condition. And remember that the bottom cannot be equal to 0. So this can be greater or equal to 0, but this can only be greater than 0, not equal to 0. Right? So the first condition, let me write it here. First condition, it is either if x minus 3 multiplied by x plus 2 is greater or equal to 0. Before we take the second one, let us find the solution to this problem. Talking about the roots will be +3 and -2. So if we have y and x axis, we locate -2 here. This is -2, and we locate +3. These are the values that can make this to be equal to 0, right? Because the leading coefficient here is positive, we should expect an open up parabola, something like this. It will pass through -2 and +3. And we are talking about greater or equal to 0. Where are the values of y said to be greater than 0? Above x-axis, right? So everything on this leg, from -infinity down to -2, including -2. Then we have from 3 down to +infinity. Everything here will make y to be positive. So the solution here is what? X belongs to the set of values from where? -infinity down to -2, including -2, union from 3 down to +infinity. So this is the solution to the first inequality. Then the second one, we have to take this x minus 1 multiplied by x plus 5. Remember, this can only be greater than 0 because it cannot be equal to 0. So what are the roots? The roots will be 1 and -5. So let me use this one. So if we have y and x-axis like this, we are going to locate -5 to the left, -5, and +1 to the other side. It's still open up parabola, right? Something like this. So the solution would be from -infinity down to -5, but excluding -5 because this is just greater than type, while this one is O equal to. Then we have from 1 down to +infinity. So if you unite the two, you have your solution. So x belongs to the set of values from -infinity way down to -5, excluding -5, union from 1 down to +infinity. So you see, this is the solution to this, while this is the solution to this one. But we need to unite the two solutions by taking intersection, right? So what is the intersection between these two solutions? Let's find them out. So if I have a number line where the center is the origin 0, let me start with the first solution. This is the first solution from -infinity down to -2. So we have -2 here. It means from this 2 way down to -infinity, right? And we have from 3 down to +infinity. So if we have 3 here, this is what it means. Then the second one here, we have from -infinity down to -5. So you should know that -5 will be somewhere here because -2 is greater than -5. So if you're talking about this one, it will be from here down to -infinity. Remember, -5 is not a solution. This is why we have this open cycle. Then from 1 down to +infinity. 1 is here before 3. So it is somewhere here. So where is the intersection? You see, these lines have intersection here, just from -5 down to -infinity. Now if you draw another one here, this is where they're intersected from -3 down to from +3 down to +infinity. So the solution, if taking the intersection, we have from -infinity down to -5, then union from 3, but 3 is a solution, remember, way down to +infinity. So we are done with the first solution. Let me write it somewhere here. We have -infinity down to -5, union from 3 down to +infinity. So we are done with the first condition. Let me wipe everything here and take the second condition. Then the second condition is either if this is less than 0, likewise this is less than 0. If they are both negative, if you divide them, you shall obtain positive because this is positive. So we have x minus 3 multiplied by x plus 2. The whole of this should be less than or equal to 0. And what are the roots? The roots will be 3 and -2. So we have something like this. -2 is here. Then we have +3. And you know it is open up parabola. Talking about less than, we only have solutions here. Less than, values that are what? Less than 0, they are all negative. So this is where we have negative y-axis, right? So we expect our solution to be from -2 down to +3. So this is the solution. X belongs to the values from -2 down to 3. We do the same thing here. For this one, we have x minus 1 multiplied by x plus 5 less than 0. Do not say less than or equal to because the bottom cannot be equal to 0. The same thing, I don't even have to construct this. The roots are what? -5, +1. So x will belong to the values from -5 way down to +1. do not include them because this is just less than type. So let us take the intersection between these two values. Let me show you how to do that. I want to show you everything. I know I can do that without number line. So if this is a number line, we have the origin 0. Let's start with the first one from -2 down to 3. -2 here, 3 here. We mean from here down here. This is where we have the solution. What about the second one? From -5, if we have -5 here, down to 1. 1 is somewhere here. So we have this. So where is the intersection? The intersection is from here down here. So it's from -2 down to 1. -2 down to 1. But remember, -2 is a solution. Look at it here. It's part of the solution. So you cover it with a square bracket. But 1 is not. Remember, it cannot be equal to 1. So we cover it with parentheses. So this is the second solution. So in general, we're going to take this and unite it with this one to get final solution. So the general solution to this problem, we have x belongs to the set of values from -infinity down to -5, excluding -5. Then we can take this one from -2 down to 1. Then lastly, we have that one from 3, including 3, down to +infinity. So this is just the solution to this inequality. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Subsequently, I'm only going to change this inequality to less than or equal to, and it could be just greater than type or less than type. Bye bye.